case you're in the wrong room, this talks about Elasticsearch. So, I delivered this talk, I think, yearly at Devnexus for the last, 5 years or so. It changes a little bit based on the questions I get the prior year. So I think after like 20 years, I might have like the perfect presentation. This presentation touches a little bit on Elasticsearch, kind of the foundations and how it's deployed, and its failover, and its REST API, things like that are briefly touched on. But I'm mostly talking about how to get Elasticsearch to scale for big data processing. So we're talking fast reads, fast writes, aggregations, and stopping it from falling over, which seems to be a pattern, right, with Elasticsearch. It seems to let people get started quickly, and then everybody seems to hit a brick wall at some point. At least that's my experience when I end up talking to DevOps and development groups. So, who am I? So I wrote a book, Elasticsearch in Action. It came about because of ElasticHQ. It is a management and monitoring app for Elasticsearch. Relatively popular, open source. It's on GitHub. It's got about 4 million downloads. So it's nice. Now, most of the talk deals with my day job, so Predicto and Volantio, where I worked. Mostly Predicto, where I was the VP of engineering and responsible for building out and architecting a system that can deal with lots of disparate data sources, disparate data formats, building a data lake, processing that, ETLing that, generating features from that, and then predictions finally. So the development group that reported to me also worked alongside a data science group to hopefully predict when the next aircraft engine was going to explode. Right, that's basically what it's saying. So, and we actually worked with Pratt & Whitney on something similar to that. So the agenda for today, very brief talk on Elasticsearch and a little bit on Lucene, which is the underpinnings of Elasticsearch. Big data processing, so how that worked, specifically over the last 5 years. The company from inception to finally an exit by Pratt & Whitney, oddly enough. And then after 5 years, what did we learn? Not all of this presentation is a glowing endorsement of Elasticsearch. There are places that Elasticsearch sucks. So you will learn that here, hopefully. Or maybe I'm just really bad with Elasticsearch, it could be too. So Elasticsearch 101. So very quickly, who here is using Elasticsearch in production? Hands grow every year, so that's a good sign. How many of you are struggling with Elasticsearch in production? Okay, it's about a third. Okay, about a third of that group. That's interesting. So let's talk basics real quick, and then I'll get into the scaling aspects. Elasticsearch has Apache Lucene under the hood. So you could essentially, if you understand Elasticsearch's deployment layout, every shard is actually an Apache Lucene instance. Lucene, for us old guys, is what we used to bundle in our Java war and ear deployments to have our apps be able to do search, right? You used to bundle Lucene in. Elasticsearch basically started off as a distributed Lucene, a fault-tolerant Lucene, and a Lucene with a REST API on top of it. So it made it easy to use and easy to deploy. Elasticsearch is probably its biggest calling, probably its biggest selling point is the fact that it's distributed and it has fault tolerance built into it. A lot of the newer database, a lot of the newer NoSQL databases can also claim this. Back in the day, let's say 8 years ago, this was a big selling point in a NoSQL database, right? It's akin to Cockroach in that you have to try really hard to kill Elasticsearch. I'm always curious if people are able to kill Elasticsearch, how they're doing it. Document-oriented. Basically, everything is modeled in JSON. You store JSON, you retrieve JSON. Like I said earlier, there's a REST API. REST API goes beyond just searching, getting, and inserting, updating, deleting. It also exposes a monitoring and management capabilities for the entire cluster. So you do have very, very in-depth observability into what is happening inside of Elasticsearch, down to caches, buffers, transaction log, performance metrics, simply going through that REST API. Analytics and aggregations, probably something a lot of, I think, newcomers to Elasticsearch don't know. Elasticsearch originally was adopted for, again, coming from Lucene, for its full text search capabilities. It later became kind of the DevOps toolbox in that it was used basically to centralize my logs. One of the most powerful features that we used a heck of a lot was being able to do statistics, sums, ags, forecasting, standard deviations, and so on through enormous data sets. And Elasticsearch does this really, really quickly. Has an ecosystem. There's a company behind Elasticsearch. They actually have a booth outside. First time ever at Devnexus, so that's nice to see those guys here. It has a healthy ecosystem. I think it always has had a good following from the open source community. Client SDKs, just a word of advice, I would stick to the officially supported ones. So I think that's Java, Scala, Python, maybe a few others. Go, I think, is officially supported. Monitoring apps, there are free ones. They're open source. They offer their own. And if you go on Elastic, they offer all sorts of stuff for Elasticsearch. So if you have the budget, feel free to spend your money there. Okay, so this was an original slide from how does a search engine work? A lot of us are used to select star from where like something, right? And we're doing wildcard searches. That's not how Elasticsearch works. So Elasticsearch uses an inverted index. Inverted indices are extremely simple to understand. We take our docs, so we have, let's say, 6 documents, just big JSON blobs, and we're going to tokenize them. And that means we're going to split using a default tokenizer. We're going to split on spaces. We're going to throw away punctuation. We're going to throw away stop words, just using the basic tokenizer here that Elasticsearch comes with. So we're splitting on words, basically, on main words. And we're tagging and saying, doc 1 has oranges in it, doc 2 has apple and oranges in it, and so on, right? So that's my inverted index. When I run a search in Elasticsearch, by default, Elasticsearch can be a little greedy. So until you learn how to formulate your queries using the QDSL, the query DSL, it can get a little tricky. So in this case, I'm searching for apple and peach. Presumably, document 2, 3, 4, 5 all hit. If pineapple was in one of these documents, it would probably hit as well, right? So again, it's greedy by default. This is a money slide. I have no idea why, but people love this slide, so I'll just keep it up for a little bit. It is just a terminology mapping, the best I can do. So take the MySQL world, which is what I'm familiar with. I think Postgres might change a little bit because their idea of a schema is a little different. But one thing that I will point out here when it comes to terminology is that in the Elasticsearch world, the word index is a noun and a verb. So you can index something, which means I am inserting it, and presumably it's being added to an index, the fields are. And then there's the noun index, which is my database. Right? And I'll get into the splitting up here in a little bit. One thing with Elasticsearch, by default, every document you put in there, every field is indexed. So if you have a 200 field JSON blob, every field is going to be indexed. Extremely powerful if that's what you need. If you don't know beforehand how your data is going to be queried, this is nice. It gets you out of that relational world where, oh, I should have put an index here. I should have put an index here. I should have normalized this, right? And now I have my DBA running around crazy. More terminology here. Elasticsearch defines a cluster as basically a group of nodes with the same name. That's how it does discoverability. Just as a best practice, try not to name your clusters, different clusters with the same name. There's actually an open issue in Elastic HQ just for that, and I have no way to work around that. Newer versions of Elasticsearch will actually have a unique identifier for the cluster and the name. So you can uniquely identify two clusters with the same name. Older versions, like version 2, yeah?
Sorry, when you say the cluster, don't name the cluster with the same name. Suppose I have a dev cluster, test cluster, production cluster.
Yeah.
So you don't want to.
Yeah, name one dev cluster, name one test cluster, name one prod cluster. Yeah. Or you could just have one cluster and keep your indices, but that could affect your testing, right? So, yeah. A node is one Elasticsearch instance. It's one Java process. Elasticsearch is written in Java, by the way. I guess I should have started with that. A shard, like I said earlier, is a Lucene index. If we want to see how things are broken down here, essentially your indices, your databases, where your data is broken up into shards. And shards have primaries and replicas. So the beauty in this is that I can have an index, so a database with all my documents in it, right? And I will say, I want to break that up into 5 shards, each of them with one replica. So if a primary shard goes down, one of the replicas will then assume a primary position, and it will actually create another replica in its place. So Elasticsearch has a concept of fault tolerance built in, right? And almost like a self-healing built in. One word of note, you can never change the number of primary shards in your index. So once you've created your index and say, I want 5 primaries and 1 replica, if every shard in that index becomes 500 gigs, you're going to have a very bad day because you can't change that. So you will literally end up having to re-index your data into an index with more shards. So basically, I want to split my data up even smaller. I'll get into that in a little bit. That is one of the biggest causes of hair pulling. I have no hair, you see. Hair pulling in the Elasticsearch world is the fact that you can't re-specify that. All right, when should I consider Elasticsearch? I'm assuming more than half the room already went through this calculus, and about a third of you are regretting it. But hopefully we can get you guys to love it again. I guess this goes without saying, right? I want my database to be fast at reading, fast at writing, and fast at doing ags, right? Sums, max, min, standard deviation, and so on, counts. Big point, number 2. Elasticsearch is eventually consistent. Something I see a lot in the wild is people taking Elasticsearch and trying to force it to be consistent. And I'll get into that later. There's ways you can try to do that, but you're going to hammer the cluster into submission if you're writing a lot to it. Eventually consistent means I tell Elasticsearch, index this document, and it adds it to a buffer, it appends it to a transaction log, and at some point, it will flush the transaction log into the actual index. So when I write to Elasticsearch, and then I say, give me that file I just wrote, it may not be there. It can't get it. Just keep that in mind. Again, if I can model my data in JSON, maybe a good fit, like Couch is as well, Mongo, right? If you need everything indexed, in our case, we did, because I didn't know what my queries were going to look like. Every customer's data was different in my case. So I needed literally everything indexed, and I could not go with a normalized data model. There were business reasons why, but in my case, in all our cases, I guess, if you could denormalize your data and don't feel dirty about it, Elasticsearch might be a good fit. I would say highly denormalized is preferred. One thing I never allowed, and for performance reasons, was nested structures in Elasticsearch. Try not to do that. It actually slows things down, performance-wise. Schema flexibility. Elastic might define this a little differently than I do. In my world, that was the ability to coerce a string into an integer field. Because I had customers that one day would give me a timestamp in that field, and one day it was a string, and one day it was a float, and I could not do strong typing for that reason. No transactions. That goes a little bit with the eventual consistency. Just keep that in mind. Okay, token slide, because most people use Elasticsearch. Let's just say maybe 3 years ago, most people used Elasticsearch in this model, right? This pattern is I have Logstash, well, I have a log files, right? I have Logstash or FileBeat, and it's pushing data into Elasticsearch. Logstash might actually be transforming the data in some way before it gets to Elasticsearch. And then I have Kibana. My DevOps guys presumably are sitting there staring at a Kibana dashboard all day, or clicking around, running reports. I don't know what DevOps people do with that, but I do. So just here for, I think most folks are still using Elasticsearch in this way, although that is changing. So big data processing. We dealt with a lot of data at Predicto. It was coming off of aircraft engines, key cranes. It was coming off of locomotive engines. It was coming off elevators, you name it. So it was always different. And then we peppered in atmospheric data. So we had NOAA data with geolocation, because the things we monitored were big, expensive things that moved around. We also had NASA particulate data, because particulates up in the atmosphere affect aircraft engines differently. So we want to predict the effect of those particulates on my aircraft engines. How it worked. This was a typical onboarding. Typically, we would go to the customer, big deal was signed, big check was passed from one hand to another. I never saw it. First step is, dear Mr. Customer, I need all the data you have. So usually there's hemming and hawing. There's a lot of politics you have to deal with CSX and Norfolk Southern and Pratt & Whitney and Carrier and Otis and all the big boys, right? So data is often siloed, and you have to work your way around that. Eventually, I get my hands on 2 to 3 years of data, and it's in all sorts of formats, right? So I need to ingest that. I need to ETL it into Elasticsearch. I need to generate features. What we did was a little novel. A lot of the feature generation was dynamically done, more or less guided by Spark. Training our models didn't really impact Elasticsearch all that much. Issued predictions, again, not a big Elasticsearch thing. And then visualization, nice reading dashboards that we would have for our customers. Important parts, ingesting data, I needed really, really fast writes. Generating features, I needed extremely fast reads. So we'll get into that. This is a marketing slide. So our our machine learning stuff was called Max. It was actually just a bunch of Python microservices using scikit-learn and scipy, things like that. The important part's at the front. So not only would we consume data from the locomotives, the cranes, and the things, the sensors, we would also pull in maintenance data, work data. So the guy with the wrench that is fixing something, I want to track that because that's going to tell me what broke, and that's how I can do predictions. Weather data, like I said before, was also added. So for every row of data that came in, I am appending weather. I might be appending other things to that, and you'll see the other things now. The other things are the features that we generate. So data comes in, and typical customer, maybe when we denormalize the databases altogether, all the siloed pieces, you end up with maybe 200 columns of data, right? So this locomotive, at this point, geolocation, weather data, maybe workman data, maintenance records, data, stuff like that. That's one row. Data scientists come along and say, I want you to generate features, and now my 200 columns turn into 20,000 columns. So these documents get really, really big. The databases that we could have used start to shrink down. I think Postgres at the time had a cap on 1,600 columns, so that just simply wouldn't work. Redshift, I think we ran into the same problem. An example of feature generation. So feature generation, these are some examples, and this is what the data scientists would tend to kind of concoct, and Spark would take this a little further, but for every row, I want to know max temperature of every locomotive engine per week. So append that. Feature 3, nearest local outside temperature for a train based on lat long. So presumably, I have to go look at the lat long of that row as my little train is moving, or my airplane is moving. So I pick up the lat long, and now I go to my weather database, match the nearest temperature, and append that to that row. So my rows start to grow, right? Our little formula at the bottom, number of rows, number of features, number of queries. So we targeted 10 milliseconds for queries. Again, every row is going to issue thousands of queries. I have to onboard my customers because the sales guys and the CEO sold a 30-day pilot or a 90-day pilot, right? So I need to have 90 days. I need to have results, all their predictions of all this stuff that could have broken down and we could have saved them money, right? So 10 milliseconds is fast until you get into these numbers, right? When I got 100 million queries, which is not that far-fetched, it's taking me several days just to run this job from Spark and Elasticsearch. What helped us is that this was all done in parallel. And I'll get into that in a little bit, but Elasticsearch, obviously, many nodes. And the query sources, so where these queries are being issued from, in our case was Spark. Spark has, I'll get into it in a little bit, but Spark allows you to not only parallelize data processing in memory, but along with Elasticsearch, it actually scales with Elasticsearch. So if I have 5 Spark nodes, 5 Elasticsearch nodes, I can literally quintuple the throughput. I'll get into that. I think I talked about a little bit of this, right? How onboarding's worked. Customer gives us tons of data. I learned to be cynical over the last 5 years. No matter who tells me how clean their data is, it's always a disaster. And it's a disaster in a weird way where you can't code defensively against it. We would end up with timestamps that are 20 years in the future. And again, the typing, right? Longs, ints, strings. Like it seems like whatever databases these guys were using was just whatever, right? Whatever fit is what they would cram in there. I don't know how you end up with a 20-year in the future timestamp, but I think we get the picture now from an architecture standpoint. We knew what we needed to build. We had a prototype that used Pentaho and Postgres, so we knew what worked but couldn't scale the way we needed it to. So we needed fast read. It was all time series data in our case. Fast writes, obviously during ETL. We were already set on Spark, good. I wanted it to be cheap and easy to deploy on Amazon, highly available. Dynamic queries, because as you saw earlier, when I'm generating features, I have no idea what the queries are going to be. So in a relational model, this kills the database. With Elasticsearch, the queries could be anything. Everything's indexed, so everything presumably is fast. Schema flexible, like I said, timestamp, string, long, int, just swap them out. GeoJSON was nice from a weather standpoint, right? So given a lat long or some geo point, I could find that nearest weather station, right, to my expensive thing that's moving around, right? These are the databases we looked at. Now remember, this is 5 years ago, right? There was no Cockroach. Couchbase was probably something I wouldn't have looked at, although I use it now and love it. Back then, it wasn't even on the list. Cassandra, I was comfortable with. If you want to write fast, Cassandra is write fast. But I have to know my queries beforehand. So that wasn't going to work. Relational, I have column limits. I have failover issues. No. Mongo, web scale, right? I didn't know Mongo well enough. None of my developers did. So that could be on us. Maybe Mongo could have done the job. Not sure. Solar was a contender, because Solar has Lucene under the hood as well. 5 years ago, though, Solar wasn't where it is today. I believe 5 years ago, it may not have had a mature REST API at all compared to what it has today. Hadoop, it was a big rage 5 years ago, but I needed parallelized and I needed my stuff memory bound. I didn't want to go to disk. So what did I learn? I don't know how I'm doing on time. What time does this end? Okay, because I'm racing through this. You guys aren't asking questions. I don't know if you guys are awake. Or I'm just mesmerizing. There it is? Okay. Okay. All right, so how did it end? There's something to be said for how it ended, right? I mean, I think over the last 4 years I presented here, and I was always talking about how we're building things at Predicto, right? And then UTC came around and bought us, right? It was a good acquisition. Predicted failures across lots of big, expensive things that move around. That's basically how we would put it. Basically trying to minimize downtime, right? Trying to tell locomotive guys, hey, this locomotive is going to have a failure within the next 30 days. Here's why we think. Here's where you should look in that massive engine, right? And it was a good value prop. So the company got acquired, and we had a lot of POCs. It's a tough space to be in. There's a lot of competitors, right? You have the Accentures of the world. I guess you have IBM with Watson, even though that doesn't really, it's kind of vapor, but whatever. Sorry, I know they're a diamond sponsor, right? I may not be here next year, is what I'm thinking. Yeah. So it's a crowded field. So we had a lot of POCs. We had no real recurring revenue. Just a lot of POCs, right? Upfront check, thank you. We can predict, what's going to break next month, next year, right? So UTC wanted the tech stack. And that was good. That made me feel good. It's like, hey, somebody's finally buying something I built, right? Right? All right, so what if I skip something here? No, okay, all right. So lessons learned. It's basically the meat section of this whole thing. When deploying on Amazon, this is a no. Don't get started on Amazon unless you use the Cloud Amazon plugin for Elasticsearch. It makes your life a lot easier. I tried, I think, in the early days deploying without it, and I could not deal with Elasticsearch now being able to see other nodes in the cluster. So it really makes things a lot easier. Obviously, they should have the same name and the same security groups. The ports for Elasticsearch, 9200 and 9300, you open those up in the security group. Extremely important. You set the IAM role at creation time on the EC2 instance. You can never change that again in Amazon. I don't know how many people knew that. I discovered it, and it was really painful. When I try to add an extra node, and I can't, that's a problem, right? So Elasticsearch could be configured to do unicast or multicast for discovery. I think by default, it should still be at multicast. I always left mine at multicast, as long as it could ping out and see other nodes in the same role with those ports open, same cluster name. It'll find its brothers and sisters out there, right? This is an interesting one because this happened over the last, I don't know, year, something like that. I think about 3 years ago, Amazon released their Elasticsearch hosting. It was an absolute disaster when they rolled it out. It's still a disaster. I would never recommend using the Amazon Elasticsearch. A lot of people get started with Amazon Elasticsearch because it's really easy and you think it's going to be like every other Amazon product, right? They make things just easy and powerful. Configuration is lacking, so being able to go in and actually tune Elasticsearch is not going to happen on Oz Elasticsearch. Shard rebalancing, last I looked, is broken. That means if one of your nodes is, let's say, filling up drive space, and maybe it goes down, if you bring other nodes up, the shards won't rebalance. Amazon actually recommends blue-green deployments, which means if your nodes are running out of space and your shards won't rebalance because they can't for some reason, I don't know why, you set up a different cluster, copy your data over with the right shard allocation, and now shut down that one and use this one, right? Now, if I'm reindexing terabytes of data or petabytes, that's going to take days or weeks. So it's a non-starter. If you're just playing around with Elasticsearch, by all means, use it. In production, I wouldn't. Today, I don't know if Amazon Elasticsearch is actually their forked version. So for those of you that may not know, Amazon forked Elasticsearch. They don't call it a fork, but it's a fork, right? So, I mean, it has its own repo. Looks like a fork. Smells like a fork. So let's see. This was our setup at Predicto. Eventually, we moved to the iSeries EC2 instances. We started with R series. They were memory optimized because we lock memory on Elasticsearch. I want all of Elasticsearch to run in memory. I don't want it going to swap. I don't want to use disk. So we went with R series, and then we would EBS mount. We would use EBS mounts, right? So 500 gig mounts. A more optimal configuration is going with iSeries, 60 gigs of RAM. We would give 30 gigs to heap, and then use the local SSD storage, which is what the iSeries, I think, gives you, right? The interesting, I think everybody knows this with Amazon, is as you upgrade into the i2 XLs and the higher instances, right, the more expensive instances, the network grows, right? So you get the benefits of a 10 gigabit network when you go up in RAM and CPU, right? Yeah.
So we're talking about dynamic data. So how did you do the sizing of the cluster? And also the shard sizes, how did you manage the shard?
I actually get into that towards the end, but there's a slide that I have titled sizing your cluster, ... it depends. nobody's going to be able to give you an exact formula on how to size your cluster because and I'll get into it, there's a lot of factors involved. The size of the data, do you want it to be fast on indexing? Are you batching? Are you streaming indexing? How are your reads? How are your searches? Should you be indexing everything? Storing maybe a few things? So there's a lot of factors involved there. I'll get into that.
So what do you do with the ghost nodes in case some of the nodes go actually down while they're indexing and one of there are a couple of replicas which are trying to replicate at that point of time and it just goes down and it turns into a ghost node? How do you collect that? What do you do with that?
Well, assuming I've configured things correctly and my sharding strategy is working, if a node goes down, another node should pop up, right? You're going to end up with shard rebalancing, which is going to suck for a little while, right? I mean, your database memory is going to shoot through the roof. CPU, you're going to see your Java process just shoot through the roof as well, right? Depending on your shard size, if they're small, 20 gig, 30 gig shards, it'll move them around the network. Not too bad on a 10 gigabit network, right? I've never had a situation where a node goes down and my whole cluster just halts, right? Elasticsearch was actually really good about kind of healing itself. Yeah. Are you having this problem? Yeah. We'll talk.
Whenever the balancing occurs, there is always a memory spike.
That'll never stop. That's always the case. Whenever a node goes down, the rebalancing happens and the cluster gets hammered. Yeah. The key is to not let the nodes go down, I think. So here there's a mixed success here. When I originally deployed our Elasticsearch clusters, I put Nginx in front of it. I thought I was being clever because I could do round robin proxying. I could log every request, every query that comes in, so I could look at how long these things are taking. Common knowledge today is don't use Nginx for proxying. This is actually recommended, I think, by Elastic. Instead, use their client nodes. Having Nginx as a proxy apparently affects how the individual node caches work because it's going round robin. I never noticed performance hits, but just keep this in mind if this is what you're doing. Also, if you're going to put Nginx in front of this thing, now you can't have a M3 medium for Nginx, right? You're going to have to put this thing on 10 gigabit network as well, because having a slow proxy defeats the purpose of having everything else on 10 gigabit behind it. This was an aha moment for us because I inherited a Python shop. Not a Java shop, not a Scala shop. This was a Python machine learning shop. And I, coming from a Java background, had concerns with how do you parallelize this thing? Because of the GIL, Python's just not going to make use of my cores. So Spark came in. And the beauty of Spark is that with the Elasticsearch Hadoop connector, it actually communicates Spark node to Elasticsearch node. This gave us the capability to run Python, build a Python team, and build to scale just with this. Now, we use PySpark, yeah. So this was a big game changer for us. There's a few caveats. I did, the node-to-node connectivity. One of the things our DevOps guys did later was allow for Kubernetes to manage Spark. So we'd have spot instances that would come up depending on load. That was nice. One thing with this is that if you have Nginx in front of it, it will ignore Nginx. It'll actually, the first request that Spark makes through the connector is what are the nodes and their IPs. Every other call, every query, it'll ignore Nginx and connect directly to the nodes. So just keep that in mind. You're not going to see any traffic in your proxy. We ran into issues with typecasting. Again, remember, I would put strings and integers and strings, and all sorts of malformed stuff that nobody in their right mind should do, but we did, because we didn't want to lose data. The Hadoop connector is written in Java. It has strong typing. Elasticsearch allows you to shove a string into an integer field. So it's defined as an integer. And now when I retrieve that document, I try, the Hadoop connector tries to cast it as an integer, and it finds the word hello, and it blows up. I ended up forking that, and we used my forked version. Considering collectors for throttling writes, we had some of this in our pattern. Being able to have writes in a rabbit queue, have documents in a rabbit queue or Kafka, and having collectors that would push the data into Elasticsearch in bulk, right? If you guys have played with Akka Streams, it comes with back pressure, and it allows you to do stuff like this and not kill your database. Always use the bulk API. This is a given with Elasticsearch. Don't go hammering it with 1 million index requests. For fast writes, this is really dangerous, but on initial onboarding of data, we would sometimes reduce replicas or disable them entirely, which means if my nodes go down, I'm dead. I got to start all over again, right? But this stops my data from replicating everywhere and makes writes faster. Setting the refresh to not happen at all means I'm going to insert as fast as I can to this database, but I'm not going to be able to search on it because I haven't refreshed. So it doesn't know there's any data in there. I'll stay away from tuning the file system cache and some of the other buffers and caches. There's a lot of levers and knobs, and it's probably best to not just go swinging a hammer around, but there's plenty of articles online, even on the Elastic site, that can help with a little bit of this, right? Using auto-generated IDs, we actually found performance improvements doing that. Before, we would actually take an MD5 of the JSON document and shove it in there because we would get a lot of dupes. All right, fast reads. Like I said earlier, disable swap. I don't want my database going to swap. 30 gig heaps, don't go bigger than that. Java doesn't do well bigger than that unless things have changed. Mentioned earlier, this is actually even on the Elastic site. Nested and parent-child relationship structures do make certain querying in Elasticsearch slower. Try to avoid them. We decided as a group that anything over a second was a slow query, so we'd log it out. It's more observability than tuning at that point. Some of you should already know this. If you're dealing with time series data, you organize your indexes by time. So call an index month, day, year, or month, year, and so on, right? It keeps those indexes nice and small, and when you don't need them, you can close them and archive them, right? Avoid sorting, scripting, and wildcard queries. Try to sort in code. Hate to say that, but scripting, I never allowed an Elasticsearch just because I was always scared of getting hacked to death. That may have changed, but back in the day, it was a security hole. Wildcard queries are slow in every database, right? Increasing the refresh interval, same thing, right? So as the writes. Refreshing, just so you know, is an expensive operation in Elasticsearch. This is probably the most important slide. Probably I had to deal with daily. Don't abuse refresh intervals. I know there are folks that, again, fight with the fact that it's eventually consistent. And they will hammer Elasticsearch with inserts. And with every insert, they issue a refresh call. And your cluster is going to die. Like, that will not scale. It's an expensive operation. Disable dynamic schema creation. I had to learn this the hard way, but we had a lot of PhD data scientists that had access to Elasticsearch, and they would just put in documents, and they would just add fields and create stuff. And that would just give me headaches later on, right? Think through stuff. Elasticsearch, this probably goes back to denormalized JSON is not a data dumpster. Elasticsearch is not some JSON garbage dump, right? Where developers don't want to deal with data architects. They don't want to deal with DBAs. So it's like, well, there's this JSON store. I'll just cram everything in there. Who cares, right? Somebody else will deal with it. The DevOps guy will figure it out. So think through schema. Think through sharding strategies, mapping types, things like that. How are your queries going to be on this thing? Is it full text? Am I having to tokenize differently? Things like that.
You said set explicit mappings and all of that, and thinking your schemas, but wasn't that one of the reasons why you went with Elasticsearch initially, so you didn't have to know exactly what the data looked like?
In our case, yes.
Mappings.
Yeah.
Yeah, same thing. I mean, I think most.
However, when we would create mappings, we learned this later, we would insert our data. Again, some of it, I didn't know what it was. We actually had scripts that would, it's kind of ugly, but we would denormalize all our data, so it would all get pulled in together, right? Our data scientists had Python scripts that they would run through and select the first 100,000 rows, or whatever amount of rows, and type that. And from that, we would create our mappings, yeah. It's a horrible hack because if your 101th row is typed differently, you blow up. Yeah. We also added, for every string that we would insert, every string type that we would insert, we added a non-tokenized string version of it as well, which made our data explode, but it is what it is. Yeah. That bottom one, I had to train my developers to think this way. You're not using this like Postgres, where I'm joining 10 tables and doing an order by and so on, right? Groups and all this stuff, right? Think atomically. So very small atomic queries. I'm more than likely going to have better performance doing that with Elasticsearch because it makes use of the cache. Having one big query tends to not be Elasticsearch's forte. All right, this is your slide from earlier. Cluster sizing. I don't have a magic formula for you guys, and I know this is painful because up front you don't know. And we ended up re-indexing a lot, and that's how we ended up building Akka stream stuff with back pressure built into it and so on. At first, even Elastic recommends less than 50 gigs per shard. Start there. Time-based data I talked about. Try to split up by time. The newer versions of Elasticsearch allow you to split indexes and roll over indexes and then put aliases on top of them, although aliases have always been around. The splitting is nice. That's a nice feature that Elasticsearch added because you can't redo your primaries. So you kind of have to do this, right? There's a lot of factors involved, more than this, in determining sizing. How long do you want to keep your data? Is it an index-heavy or a search-heavy database? How am I inserting? Am I streaming it in? Am I doing batches? We did batches. And how much data am I willing to lose safely and not get fired? Right? That's always an important one. Yeah.
What would you say on the smaller side of the scale?
For a shard?
Yeah, so as a startup, I might have 2 clients, and I'm pumping being a relative term, but trickling data in. When I was first looking at the guidance, it's like, okay.
If you have small data, even the Elasticsearch 5-to-1 default is too much. Like maybe 3-1 is where I would start and go from there, right? But you're talking maybe on the small side, if I do 3-1, I'm looking at maybe a gig per shard, right? Yeah.
I think they said 35 to 50 gig.
Elastic. Yeah. I've heard 30. I've heard 50, and yeah. So we always shot for this. So we tended to be a terabyte to 300 gigs, I'd say, is where we sat with most customer data. A terabyte is pretty nasty to deal with, but yeah. So I made the big bucks, I guess, right? So. Very helpful. Curator. So Elasticsearch, I think, hired the guy that started Curator. I'm not sure. Don't quote me on that. But Curator used to be off in its own GitHub repo. Elasticsearch now brought it under its own repo. So it's all bundled together. You might have some trouble looking for it. Just search for Elasticsearch Curator. This is what automated the tasks of being able to create new indexes by month, day, year, let's say, creating new aliases, snapshots. So with Curator, you could have your Elasticsearch cluster backed up every hour, every night to S3. Really handy. Just cron it, you're done. And the backups are incremental. And you can even restore specific indexes if you want. So it's really nice. I've found myself, whenever we had to move data around, instead of copying from one index to another and trying to build some hack to do that, I would just set up a whole new cluster and then just restore from backup to that new cluster. So, and that's how we tested if backups worked. So big data. Archive closed, unused data, like I said before. Don't keep stuff open and lying around unless you need to. It's taking up resources for no reason. Partitioning data, I think I talked about this, being able to break up your indexes and put aliases over them. Curator helps a lot with this. Try to avoid reindexing. I know it's nasty, but if you didn't size correctly, you're going to reindex. And with a terabyte of data, this is extremely painful. Like, I don't ever want to do that again. I've never seen this happen, but it's all over the Elasticsearch site. And I'm assuming this happens to somebody somewhere. This is the magic formula that you should use when you are defining how many electable master nodes you should have as a minimum to avoid split brain. Does everybody understand what split brain is? Is anybody awake? No. Split brain happens when you have a network break and you have two masters that end up on the other side of this, and they both think they are the master of the cluster because one just got elected as the master of the cluster. You will end up with data falling out of sync. I think we're almost at the last slide. So this goes without saying. Important slide. Choose the right tool for the job. Don't listen to the developer that just reads Hacker News all day and wants to try out Haskell and Rust and whatever cockroach stuff he's looking at. Sit down with the team, evaluate. What are the problems I'm trying to solve? What makes the most sense? Do I have the talent in-house to manage this thing, right? Some examples, right? I don't know, key value store. I guess you could probably use Elasticsearch as well. I'd lean towards Redis. Graph database, I've never worked with one. Neo was the only thing I could think of, so I threw that in there. Elasticsearch apparently supports graphing. Don't know, never used it. Relational database, I've become a Postgres convert, so I don't use MySQL anymore. So, that's it, questions? Anything else you got? That's a money slide, to use this every year.
I have a very basic question.
What's that?
I have a very basic question.
Okay.
I understand that Elasticsearch is good for text. It's searching because of inverse indexing, right? But it looks to me in your presentation, because you're presenting in Spark, you are trying to use for any generalized data, things like that.
No, with Spark, a lot of the analyzing actually happened in Spark. Some of the queries were date range queries, maxes, mins, counts, very simple things like that. Yeah, and they were really fast, right? That in Elasticsearch. Yeah.
So once you are using Spark, most of the stuff is in Spark.
Most of it,
So what I'm saying is you compare with Cassandra and other databases, at this point,
when I have a terabyte of data in Elasticsearch, and I want to know for every aircraft engine, give me the mean temperature on where it is geolocation-wise, right? That's a select per row. So I have a terabyte of data. Let's say it's 300 million rows of data. I now have to select 300 million times, right? A more sophisticated and probably a more funded company would have loaded the terabyte into memory and done those queries in Spark, which would be faster. Yeah, I didn't have that money, so yeah. That's not only that, right? So not only Spark, but Kafka, right? Yeah. So there's ways to handle that. Hadoop as well, right, if you want to be disk bound. Yeah. So.
Just curious, have you done anything with like authentication? Like what? Did you have to do anything with authentication until last?
Everything that we deployed was on its own VPC. So every customer had its own VPC. We would VPN in. I have friends that work at SearchGuard, I think is a company in New York, right, that does fronting to, they do role-based authentication.
Yeah, I mean, like what we end up doing now is just kind of like segment security.
I would go with in a sophisticated situation with money, I would go with a vendor, either Elasticsearch or SearchGuard, because I'm able to now do even row-based authentication, authorization, right? I think that's important. We just didn't need it, right? Tiny team, so.
So when you say like split the indexes based on the data,
Yeah.
if you want to search across the indexes, like how do you do that? Search
With an alias. With an alias. So if you're doing, let's say, month, day, year, I would have an alias for all of that month, year, right? I would also have an alias for all of that year, right? Or my query, I would specify, assuming I'm using a client SDK, I would specify, use these 10 indices, which is ugly, but yeah, you could do that. I'd rather use aliases. Yeah.
What is batch index versus stream index?
Batching is mostly what we did, and that we were bulk. We would get our data once a day or once a week, so we would ETL and do bulk inserting. Streaming is a lot of what I work in now, even though we use Couchbase now. Think of an event sourcing setup, right? Where every event now is an index, right? So it's very atomic inserts, right?
You said that's not like you said more bytes.
I would prefer not to. I'd rather queue those up and then bulk flush them. Yeah.
So how it matters to that one? Because it's not transactional, right? Is transactional? But Elastic is not transactional, right?
It's not?
Transactional.
It's not transactional.
So how it matters, like 1 hour versus?
It's if it's non-transactional, basically it's fire and forget. It's async, right? So I do a bulk insert. When you do a bulk insert, so let's say I have 50 records, right? So I issue a request, insert these 50 records. Elasticsearch will immediately respond with, they all worked except for these 2, right? Something like that, right? The 48 that worked are actually sitting in the transaction log, waiting to be flushed, right? And searchable and gettable, right? Yeah.
Data lake operation or 50 will be successful or will not be successful. Suppose one is bad record for some reason.
If one of them?
Is bad record.
If one of them is a bad record, that doesn't get inserted. So it's up to you and your code to handle the bad. Yeah. So again, one of the things I left there was put at the bottom on the factors was how open are you to losing data, right? Because there are times where if you're dealing with non-transactional, right? How do I verify the integrity of the stuff I'm putting in? It's a struggle. right? I think most NoSQL databases struggle with that, right?
Each JSON is how do you really batching it in your organization? How you batching it? Like each JSON is one API REST call.
For us, we're batching it at Spark. So we build these RDDs, these data frames, right? And then everything the features get added, right? So you end up with my 200 columns turn into 2,000 columns, right? In Spark memory, and then flush, right? Yeah. Each row is a separate document. Yeah. Yeah. Yeah.
So there is a separate API for bulk versus streaming and
there's a different API endpoint. And the bulk API, I mean, it's simply just a loop, right? So if you have a list or an array, right, you're just looping through and saying 50 at a time, send the bulk request 50 at a time, right? And then, at the very end, it's like, if I have 3 left over, then, send those, right? Yeah.
Good stuff. Thank you.
Thank you.